I'm recording it for, I don't know how well this will work, we'll see. It certainly worked in the past, it's not the first time I've used Simple Screen Recorder. Alright, so you all should have processing. Now, if you have any problem with it, I will just drag the window up here. The key was to just processing download, and you Google it, and I've never seen a machine this didn't load properly on, so processing.org should work on Windows, Mac, Linux of various types. The only problem is not so much with processing as it is with the graphics. So when we do the 3D graphics, yes, there is a possibility that on OpenGL some things will go wrong on your machine, but a relatively small probability. For anybody who's got Windows 11 and they were pretty stable, you're probably fine. Alright, so we're going to start, and if anybody has any questions at any time, please just call out. And if you want to ask a question and have me look, I will just gladly just share your screen. I will click into you and we'll take a look at your screen. That's the whole idea. Alright. So we'll start with the following. Processing is a Java front-end language, so it's not really a language. It really hides the details of Java from you. So everything we're going to do is Java, but they're not showing you that it's Java. So at first, it looks a little bit simpler than Java, which is why it's so great to learn. And the most amazing thing about this language is that you can write your first program as just a single line. Now that is not a legal Java program, because in Java you have to write classes. So when you write this, it's generating lots of classes for you. Wow, and my machine is like, the fan is kicked on, it's going nuts. I guess it's not happy about the fact that I'm simultaneously recording and saving. And Alright, so here we are. Size 600 by 400. The environment is so simple, there's only two buttons. Play and run. Play and stop, excuse me. So I just press play or run, and up comes the window. Alright, there we are. So can anybody tell me, you see the window here, what's the significance of 600 and 400? What did I just do? And I will kill the window. In what units? Pixels. All right. So, yep, really simple. 600 wide, 400 high. And if you're ever teaching it to somebody else, by the way, pick different numbers so that people can see the difference. All right, so that's number one. So notice, you didn't have to write a function. You didn't have to write a class. Processing is doing all that for you, but rest assured that internally, yeah, in Java, there's no such thing as just writing a single statement. You have to put it in something, but for the first program, they're doing it for you. All right, next thing. Let's say we say line 00 to 300, 400. All right, and we'll press play. So somebody tell me, where is 00, where is 300, 400? You know, what does this mean? All right, well, 300 is the X, 400 is the Y, and 00, notice, it's the top left. Okay, so X, in this system, X starts at 0 on the left and increases going to the right. Y starts at 0 at the top and increases positive down. That's the unusual thing in math. Obviously, positive is up, not in here. But unlike, that's the convention for a lot of web, like integer graphics stuff, right? Where the screen, the top left of your screen is 00, and it builds positively going down. Web stuff is all like that. But the difference is that in this language, you can change your coordinate system. They give you a graphical API that will let you control that later. All right, so I'll comment this one out. So that's a comment in C++ and Java. So it turns gray. And we can do a different one. Rectangle, 10, 20, 30, 40. All right, take a look at that one and tell me if you can figure out what's the 10. Anybody? 10 is the which x coordinate. So of the right. So basically, it's how many pixels from the left, right? So then, what's the 20? So that's from the top, and that's why it's right. It's okay. All right. So far we've written a static program. Now check. Oh, by the way, I forgot to mention. 30 and 40 are width and height, not absolute locations. So here, if I run this thing, you see like that. So it's 30 wide and 40 high. And if you got confused, if I make that 100, it'll be very obvious, because if I start over at x equals 100, see, it's still the same width, right? It's not. So the 30 is not an absolute location, it's the width. All right. So now let's go to the next level, and anybody who's programmed with an Arduino will instantly recognize this. Suddenly you start writing functions. So there are two functions in processing, and Arduino stole this stuff. One's called setup, and setup is the function that happens once at the beginning of your program to set things up. And then there's a function you can call draw here. Now in Arduino they didn't have a screen, so instead of calling it draw, they called it loop. So you have setup, which happens once. That just set your window should only happen once. And then draw, it's going to repeatedly call that rectangle to draw it over and over again. So what you have to understand is that even if you write a program with no loops in it, this thing is doing loops, and your machine is going to be working really hard. My machine, I could hear the fan kicking in big time, but that's because I'm broadcasting in video and I'm saving out an HD screen, a UHD screen, so, at God knows what frame rate. So that's why my machine is working hard. But you'll notice that your machine is also working hard. I mean, if you just run this program, your fan will start kicking in, because it doesn't know that this thing is stationary. It just keeps drawing this like 30 frames a second probably on most of your graphics cards. And it's possible it's faster than that. Yeah, my fan just kicked up another notch. So I'm going to kill that. All right, but here's the cool thing. Now you can see the animation at work. So we can say int x equals 0, y equals 0. So we're going to define variables. Now notice, we're not defining them in the function. We're defining them outside the function, because we just want to set x equals 0, y equals 0 once. And every time we're in the function, we may want to change them later. So just give me a minute. Instead of saying rectangle at 100, which is always the same, we're going to say x and y. All right, so just if we test this, you should again see it. It shouldn't move, right? It should always be at 0, 0, yeah. So the rectangle's there. It's not moving. Everything's good. But all right, so now we are ready to make this thing animate without writing any loops, without any kind of code that appears to be making decisions. You have to understand that this function draw is being called by another function which you already know. All of you who've learned C++ or Java, there is a main, right? And main normally does whatever your program does when it starts. Well, in processing, they've hidden that from you. They write main. So their main calls setup once, and it goes in an infinite loop, and it calls draw over and over again. So all you have to do to animate this thing is just change one of your variables, like here, x++, and now every time you draw, it changes. And look at that, the rectangle's moving. Now, I know like my screen is only refreshing like 10 frames a second or something, but I'm sure you can still see it. It's just going to look jerkier for you than it does for me, right? How does that look for you guys? Can you, is that all right? Cool. Now, right, so now it just went right off the screen, right? Now, is it still animating? Yeah. Right, because integer in Java is a 32-bit number, right? So this thing's going to go up to 2 billion, and then it's going to overflow and go to negative 2 billion and keep on going. So if we wait long enough, it'll come back, but I'll be dead and you'll all be old. So I forget. I calculated it once. If it's drawing 30 frames a second, you can work it out. It's at least decades. It's going to take a while. Maybe I won't be dead, but it's going to take a long time. All right, so my machine will be dead if not me. So we're not going to wait for it. If you want to see that, actually, here's a cool thing you could do. Instead of making this an int, in Java there's a short, right? A short is only 32768. It's a 16-bit, so it goes up to 32767, and then negative 32768. So it's 2 to the 16th, but positive and negative, so it's actually 2 to the 15th. But even that's a little bit big. I don't want to wait that long. So we'll do the really short one, a byte. Now a byte goes from negative 128 to 127. Now you're going to be able to see it because I guess that's 127, and there, it went to negative 128 and it kept going, right? So it's doing this. So there you can see it going forever. All right. But we're going to go back to integer. All right. So the first thing I want everyone to do now, I mean, you all know at least some programming language. You've used C++, most of you, or some of you Java, some of you both. How would we say, if I get to the right edge of the screen, then I want you to jump back through hyperspace and start over at the left. So it's going to be if something, right? What's the condition? How do I say if you're off the right edge of the screen? Okay, now if I say if x equals 600, this gives you an error you'll see in Java. So this is illegal. What's wrong with using a 1 equal sign? You're right, but you just said equals, but you need 2 equal signs. Just like if this says is it equal, as opposed to single equal sign which says make it equal. Now in C++, this would just return true, so it would always happen. And you'd be really surprised when all of a sudden, wait, what's going on? It would always go to the right. But in Java, true is not non-zero. In Java, true is true and false is false. You can't play this game. So all right, at least it catches us making a stupid mistake. Java's much stricter. So okay, we say 2 equals. All right, if x is 600, then what do you want to do? How do you reset? Then x equal. Okay, let's run it. So this is good, but it's not safe. All right, we're going to do it. You're going to see it works, but this is not safe code. I'm going to demonstrate why it's not safe. Yep, it worked, right? Okay, so suppose I want to go faster. I can't make my graphics card faster. It is what it is. But I could say every time you redraw the screen, jump by 2. So at a cost in jerkiness, right? It's going to go twice as fast. All right, and then it gets the right, and it jumps back to 0. So far it's still working, right? And if I did 3, it would work also. So I'm going to cut to the chase. I'm going to add 7. And it's gone. Why? What's wrong with the logic here? Yes, it never was equal. So what's a good defensive technique if you're coding? Never say equal because it's too easy for it not to happen. What do you say instead of equal? There you go. There you go, right? So, all right. So now, even if you did it by a number that never exactly, it at least goes, right? Now, you may have noticed that the animation is a little ugly because it's leaving a trail of itself. It's not wiping itself out. And that's because in this language, it's not really a language, in this API, right? We're using Java as the underlying language, but we're calling the graphics API in processing, which was made to be easy to use, and it's a wonderful language for quick and dirty drawing graphics. It's awesome. So that they don't by default clear the screen. So if you want to clear the screen, you have to say background. And in here you can say what the color of the screen you want is. So you need red, green, and blue. We need 3 values to colorize the screen, right? Red, green, and blue. Now if you want them all 0, then you got black. And the maximum for each gun is 255. So if you said 255, 255, 255, you'd have white. Let's say we wanted bright blue. What would you say? 00255. Red, green, blue. Okay, good. So now we have a blue background. You can see it flying on. All right. Okay, so that answers the question, why was it leaving a trail? Now you know, right? It doesn't wipe out the screen unless you ask it to. All right, but here's a cool one for you for animation. If any of you have an ambition. Now, there's no requirement for you to do anything in this course. This is just for you to, I'm giving you a taste of a lot of cool technologies that I love. And if you want to do more with it, good for you. Professor Song is not requiring it as like the price of admission. There is no price of admission. But I would encourage you to, if you see something you like in these courses, get together with a couple of friends and do it. Like, for example, you could build a video game. So I'm going to show you that if you want to do a video game, there's a really cool, easy animation tactic. Instead of drawing the background, just saying wipe it out. Now we're going to say, we're going to set the fill color to be 00255, and the fourth parameter is, oh God, what's the name of this? The opacity, right? So if it was like 255 would be completely opaque, and you'd be drawing normally, just like we just did. If it's 0, it's totally transparent, and you don't see anything. That would be useless. So I want to do something like 10. I want to draw blue, but like barely, so that you see a trail being left behind that's slowly wiped out as I draw it more and more times. So fill just says what the background color is, and now I have to say, let me draw a rectangle, 0, width by height. So notice width and height come out in hot pink because they are predefined variables. Width and height it knows the size of your window. So I don't have to say 600 by 400. It's whatever the size of your window is. So all right, so now instead of just saying background blue, I'm saying, well, draw in mostly transparent blue and keep redrawing. Every time you redraw, and now we're going to have to change the fill color. So wait, so this is going to be fill. All right, wait, let's make the rectangle bright red. How do we make the rectangle bright red? What's color red? Go ahead. 2500, there we go. All right, and we run. Okay, so you see that? Isn't that great, that effect? What you're seeing is, I can't freeze it, sorry. Oh, you know what I can do? Wait a minute, I can't freeze it, but there's something else you should know. We can say frame rate 1, so I can slow it way down. So this is 1 frame per second now. 1, 2, 3. So you see, you can watch the background's getting bluer and bluer every time, right? Because it takes a while for all those blues to add up to a blue background. And now notice that it's starting to blue out the earlier ones. So you get that gorgeous trail effect. All right. Now this isn't the fastest way of doing it, by the way, right? I shouldn't be wiping out the entire screen just to like wipe out the trail of my animation. If you really want to do a good job, you should undraw the thing you just drew and then draw the new one. Anyway, these are the kind of things, if you decided, yeah, I'd like to do a 2D video game with very, very little effort, you can do it in this API, and it's a lot of fun. So, if you wanted to do Pac-Man, that's probably a harder one, but, any of those kind of classic 2D video games, you get together with 2 or 3 friends, and you can totally do it if you want to. It would take you a few weeks of effort, probably. There's significant amounts of programming, but it's definitely doable. Anyway, just saying. And I'm not saying that has to be a project, by the way. I'm merely saying that whatever you feel passionate about, I think that'll be a good thing to do. All right. So what we have so far is we have an example where we've created a window. I set the frame rate real slow, which I will now. Well, let me save this actually. So I'll demonstrate how to save this. I say save, Control S, and it goes to my sketchbook. All right, so this will be, what is this, animated rectangle? Yeah, all right, so I'll call this S01 animate rectangle. All right, so it's gonna make that first. So at the end, I can always post a bunch of these. There's a bunch of them in my Java course already. Anyway, that's number 1, right? Let's just copy the whole thing. New. paste it in again. All right, so this time I'm going to get rid of the frame rate. Get rid of all that background stuff. Actually, I'll just keep background. Okay, so now instead of saying when you reach the right edge, I want you to jump back through hyperspace to the beginning, I want you to bounce off the right edge. How would you bounce? That's a tougher logic problem. You want to go in the opposite direction once you hit the right. So when you get to the right edge, and by the way, we should make that while x greater than or equal to width. What do you do to x? Well, what you want to do is subtract, right? That kind of thing. The problem is if every time you're incrementing, then your subtracting is just going to cancel it out. It's not going to work well. So what you need is a new variable. What you need is dx equals something. So let's say that dx is like +2. We're going to go 2 units to the right in the beginning. And we'll dy equals 0 for now. All right, so instead of saying x plus equals 7, you say x plus equal dx. So this way it's programmable, right? The rate at which the ball is moving to the right is just that thing, whatever you set that thing to. So when you get to the right edge of the screen, how do you reverse direction? How do you reverse dx? Right, and by the way, faster than saying -1 times dx is just to say negative dx because there is a negate operation. So, okay, that's that. And we run this. Now watch what happens to the red box. It's going to go to the right edge and bounce and go off to the left. All right. Okay, but it went right off the left edge. So how would you make it bounce off both edges? Okay, you can combine it. So if x is less than 0 or x is greater than or equal to width, you reverse it. All right, now I just want to call your attention to one more problem with this logic. It's good now. It's bouncing back and forth from left to right. On the left side, it's perfect. On the right side, it goes off the edge of the screen before it bounces. It bounces from the left edge of your rectangle. How can you stop it? I want the right edge of the rectangle to bounce off the right edge of the screen. What's wrong with this logic if x is greater than width? Okay, so width minus, you're saying 30 because the width of your rectangle is 30. So instead, I'm going to say the following, and this is Java now. Final int, let me just call that w is equal to 30. So if the width of your box is equal to 30, then whatever the width of your box is there, we should be subtracting that there. So just good style, right? If you're going to have a number like 30, you should never have it in 2 places, because then if you change it in 1 place, you'll never keep track. So you should always try to use a symbolic constant. All right, so there we go. So now basically, there, right? So you could clearly add a second variable, do the dy stuff and make this thing bounce in 2D. I'm not going to do it for you. You can definitely do it. I'll just do this. I'll say this. dx is 2, dy is 3. Let me just run that to you for a second. It's not going to bounce, but that's okay. Oh, oops. Right, of course not. I'm not adding. X plus equal xy plus equal dy. There we go. All right. So the problem with this logic aside from the fact that it goes right off in the y direction, is that it's going to tend to be very repeatable, because you can only say dx is 0 or 1 or 2, and since your screen is an integer multiple of those things, it's going to tend to repeat itself a lot. If you want, if you want it to look kind of, it's like it's slightly changing all the time, you really don't want whole numbers, because whole numbers are, this thing's always going to be in a ratio 2 to 3, right? So instead of using int, if you use float, this is really clever, because now you can make this 1.2. Now you can't draw 0.2 pixels. It doesn't support that. But you don't have to, because now every fifth time those 0.2s add up and it rounds up to the next one. So this lets you do, stuff like 3.14, right? Okay, so I guess I'll just throw this in. You don't have to. I'll do this. And I'll give you some interesting challenges to do if you want to do something new. Oops, I don't have h. H equals 40. So there's h. And let's save that out. What's this one called? S02. I'll call this the bouncing ball. Okay, so now this thing is never going to repeat itself, basically, because 3.14 is not going to ever exactly repeat. It's not an even multiple of 1.2. So this thing is going to keep bouncing around in different weird ways all the time. And of course, you could also add a little randomness to it. You can get it fancy if you want to. So what kind of things could we do as challenges for you? Tonight, since it's just like an intro thing, I'm just going to show you what's possible, and we won't have a lot of hands-on tonight. We'll do more and more hands-on as we go through the series. And if you ever want to take a night where we just do more hands-on practice on something, I'm perfectly willing to do it. We have some room in the schedule for you if you want. What can you do here? All right, number one, instead of doing a single one, do an array of them and have more than one bouncing ball. All right, now that does take a bit of Java knowledge. You can look it up, or I could help you. But so you wouldn't say x equals 0, y equals 0, because now you want more than one ball, right? So, I mean, the obvious brute force way would be to just write it twice and then just say x2, y2, dx2. But this is very impractical, right? Every time you want a new ball, you have to write more code. So the way you'd want to do this would be float array x equal new float of 10, right? Y equal new float of 10. Dx equal new float of 10. And dy equals new float of 10. So if you wanted to try your hand at doing this, this would be an interesting one, right? Now, of course, I can't, this is illegal, what I just did, because I have variables called x, y, dx, and dy. So you would have to comment this one out and replace it by that. And now everywhere I use x, you can't talk about x, you have to talk about x of I, and you have to set them, right? So if you were going to do this sort of thing, so you might want to say final int n equals 10. Yeah, I would recommend, if you wanted to do this, I would recommend defining them all using the same size. The number of balls is 10. All right, so that would be an interesting one. Now the next level, so that is totally doable. I mean, if you're not familiar with arrays in Java, there'll be a little bit of lookup time for you to look things up, and you could certainly do this, and I'm happy to help if you want. The next one, which is a lot harder and really cool, but very, very tough, I've never successfully done it, I've come close, is to make collisions. Now, collisions are really hard, because if you think about it, when you have two balls that hit, you need to calculate where they just hit and look at the physics of it. How whatever the force was coming in, they got to bounce off like that. If there's no friction, the force is being applied normal to the contact point. So there's a lot of trig in it. I found an article on Wikipedia on it. And I got it working pretty quickly. Like 10 minutes I got it working. But let me tell you, the numerics of this are really, really subtle. So I got it working in 10 minutes, but it never worked right and never will. It's tricky. Here's the problem. Every time your ball bounces, if your ball doesn't quite perfectly stop tangent, if they go into each other a little bit, and you reverse direction, now I'm trying to think what happens here. I don't remember. Sorry. I just know that more energy through round-off error leaks into the system from all the bouncing. Every time you bounce, I think a little bit of random energy basically gets in from the calculation. So you've got to write code so that it doesn't get a little bit faster every time it bounces. So as long as you just have a few balls bouncing, you probably won't notice for a while. But if you have a lot of balls bouncing, then they start getting faster and faster and having a problem. So getting the numerics of those collisions is really, really hard. I mean, PhD level hard to do it perfectly. It's really interesting. But to do it good enough for a video game is not impossible at all. So just pointing that out. So I'm commenting these two lines out for anybody who's interested. I'll just leave it in there, but I think that's a cool one. All right. What's the next step? All right, so I think the first thing... Yeah, no problem. The next thing you should know is that help, right? The reference manual. So how do I know all these API calls? I just looked it up in the reference manual, which is now on the other screen. I will drag it back in. Okay, when you click on reference, I believe it takes this out of your computer, so you don't even need an internet connection. The reference manual, no, sorry, this is on their machine. Okay. So they have all the functions that this thing does organized by category. So that's really nice. And by the way, for any of you who like to use Python as opposed to Java, this API is language neutral. It's twofold. The first thing they did was in Java, but then later on, you can add a mode here, and you can just install Python mode, and it'll work again. It's really cool. So every function call you see here can be done in Python too. So think of processing not as a language, but as a front end to help beginners learn to program with a minimum of fuss, because you just have play and stop, and as a graphical API that lets you do these cool video games real easily. So what we're going to do now is go over some other of the 2D API that you can do, which will let you do various projects if you want to. All right, so first thing is, all right, it's all going to be void setup and void draw, okay? So that's clearly it. And this is size. So it's always size X and Y, like that. What you're going to see next time, tomorrow night, is that you can specify, oops, sorry, there should be a comma. You can specify a driver in here. And if you say, I want to draw in 3D, that's what we'll do tomorrow. All right? So you can draw in 3D, or you can draw in PDF, or all kinds of crazy stuff. So it's really, really cool. Like I said, just as a graphics API, it's way better than the built-in Java stuff. And although it's not efficient, it is the easiest graphics API I've ever used. So if you just want to draw something quick and dirty, it's really, really good. And that's what I want to show you now. So let's say we wanted to do like a map. I want to, like, draw a map on the screen and be able to have my robot, say start here and go there and do things with it, right? So what I need, the first thing is I need to be able to load a picture. Well, pictures are just unbelievably easy in this language. So what we're going to do is find us a map on the internet. So map, image, let's see. All right, so here's some good maps. I will just grab this one. This looks okay. All right. Oh, it's kind of big. All right, whatever. So I'll grab this guy. So there we are. And, ooh, wait, this is a web page. It's not giving me the image. That's annoying. Oh, I see. It's National Geographic. Interesting. How about if I just grab that image? Save image as, okay, we'll just do a smaller one. So save image as, we're going to go into C. Well, you know what? Yeah, all right. Well, I'll just put it here. It's in Git C for course, and I'm just going to call this world map. Oh, no. Sorry. Right here. I'm just going to call this world map and save. Okay. So let me make sure that worked. Let's go here. Oh, come on. I'm here in workshops. There we are. Okay, if I go up a level, see. Okay, world map. My bad. I forgot to save it as save the suffix, so I don't know what kind of picture it was. All right, save image as. What the hell was it? Oh my God! It was an AVIF. I don't even know what the hell that is. All right, let's see if it works. Never done that one before. Move world map to world map.avif. All right, so we have a suffix. We know what your picture is. Not what I wanted was a JPEG or something simple. Of course, it wouldn't be simple. All right, so you want to load a picture. This is how it works. You have to declare an object called a p-image. So, yeah, there's some object-oriented programming involved, but again, if you take this on faith, you don't have to know too much. Just p-image, image. So you just declare it. Now notice I'm declaring it outside the function because I don't want to just do it inside setup. I want to do it in setup and then have it available every time I draw. So, and I'll say image equal load image of. Now here's the problem. How do you know where the picture is? So I'm just going to assume that there's an image called worldmap.avif somewhere in here. All right. Now, what we have to do to make that work is we go to Sketch and we just say Add File. Please first save the sketch. Fair enough. Save the sketch. All right, and we're going to call this Map Viewer. All right, so we've got a Map Viewer application. So now I'm going to say I want to add a file to the sketch. Now you know that I had put it into Git, so it was in Home, Git, C, and it was called worldmap.avif. That's the file I want to add. Just open it. Okay, and it just added it to the application. So the cool thing is, all you had to know is where the file you brought in was, but you don't even have to understand how it does it. But I'm going to show you. It's real simple. Where do they put their applications? They're in Documents, Sketchbook? No. Is it just Sketchbook? Yeah, okay, so it's under my home directory. It's called Sketchbook. It's stupid, but that's what they do, so I just left it there. All right, and it's called Map Viewer. It's right there. So I go to Map Viewer, and notice under Map Viewer there is a data directory. And if we look in the data directory, There's the file, right? So it automatically does that. And notice you don't, this is really designed for beginners, right? You don't know there's a data directory. It's not your problem. You just say, I want to load that file. And when you said add the file, it put it in the data directory. You get it from the data directory. You don't have to know squat about it. But it's really pretty cool. So, so now this thing would be distributed with your app. It's just, so an app in processing is a directory containing your code, which is a PDE file. And that is not a partial derivative, a partial differential equation. PDE is a processing something or other. I don't even know what it stands for. All right, so PDE is their suffix for processing code. And basically this is a Java front end, but it's exactly the code you saw, right? Very simple. It's this, what you see, what you get. This is it, right? And now when we draw it, we just say image dot wait, is it? I think it's image of img. There, yeah, there's it. So, no? Oh, wait a minute. No, I need to give it, sorry. We should look it up in the references, but I can't just say draw an image. I have to draw an image at 0, 0. I draw it at a location. And what I could even do is not only draw it at a location, I could draw it at a location with this width and this height and automatically scale it to the size of my window, which is pretty crazy. All right, so let's check it out. Null pointer exception. Ooh, it doesn't like it. Okay, so could not load worldmap.avif. So sorry, they didn't support that one. I knew it was like a risk. Okay, sorry about that. All right, we go back. We find ourselves map. All right, map. Let's get a PNG or something that I can handle. Image. There we go. Yeah, let's just take this. Make it easy. There we go. Ooh, that's big. Yeah, whatever. As long as it downloads it, shuts up. Oh no, it's one of these sites that's going to bother me. All right. Drop dead. We just want a demo in class, okay? Save this out. Okay, saving in the right directory now. And we're just going to call this world map.png. All right. And we are going to sketch, add the file. So we add the second file. The first one didn't work. Goes in the wrong directory as usual. So we're going to go to home, get C, worldmap.png. There we go. Okay, and now we just change this to PNG, and I hope this will shut up and work. There we go. Okay, and just to demonstrate, if I drag, oh, it won't let me. Oh, it won't let me change the size by default. I have to find out how to make it resizable. But if I did resize it, it would rescale because we've said that we're drawing it to the size of the window, which is cool. Any questions? Well, you have to set up a window, but if you do this, it's going to draw it to the side. If you get rid of width and height, it's going to draw the size of the image, right? But the problem is if your window's too small, it just draws you a piece of it, right? So you have to, that tells you I got to make my window bigger, right? So we have two choices. I can go for 2000 by 1200, and you'll see more of the picture. As I recall, that picture was like 5,000 by something, so it's not even going to fit on my UHD screen. Yeah, you're right, but it's cool. It's working. All right, so this is unscaled but cropped. All right. Now you could imagine you could draw this at negative 200, and then it's going to move to the left because it's drawing part of it off screen, right? There you go. All right. So by controlling this point here, you can effectively kind of pan around the world, right? So you can already see, like, oh wow, what if I wanted to make a map viewer and just like makes it scrolls around? You could do it, right? You have the right and left mouse key doing something. You want to do that? We can do it. Here, if you just say int xy, and we're going to draw at x and y, right? We better start x equals 0 and y equals 0. What we want to do now is when you click a key or do a mouse or something, right? We want to move around. So how are we going to tell it when you press the right arrow key, I want you to move to the right, right? So first of all, can you think about what would it mean in terms of x and y if we want to quote unquote move to the right on this map? How would we go that way? Let's try. Let's try. You're subtly wrong, but let's try. You got to see it to believe it. All right. You're basically, you're close. You're really close. Okay. So the problem is, how do we do the keys? Well, the beauty of this is we know the reference manual is right here, right? So we're looking for just the word key, I think. Oh no, that's too hard. Mouse for sure. And keyboard. Okay, keyboard, right? So there's a function called key press. So every time a key is pressed, it'll just call that function. So all you got to do if you want to trap it would just be void key pressed. Now, how do you know if you spell it right? You can see this. When I spelled it wrong, it's just black like this, not bolded. But the moment I do this, it turns blue and bold. So you know this is a built-in function in the API, right? So wrong, right. Okay, so this function, we can write code that'll say if you press the right arrow key, then blah blah blah. All right, that's one. And to do the mouse one, because Nick wanted to do the mouse, that would just be there's mouse press, mouse. So you just write these functions. It's so easy. It's so nice. I'm telling you, you can write a video game real easy. All right. Okay, so key pressed. So now we need to know. Let's just look at the function. All right, so if the key press function is called once every time a key is pressed. I'll blow that font up so everyone can see it. All right, for non-ASCII keys, use the key code variable. So there's a variable key code that'll tell you what it is, and all right, so the problem is I don't remember all the keys. So you want to say basically if key code, so it turns pink, you know it's a built-in variable. That's a variable inside the applet. So so that's right. If I said it wrong, then you know it's misspelled, right? So if key code is equal to, now the problem is I don't know how to say right arrow, right? Let's try. I'm just going to take an inspired guess here. Key right. And no. Okay, so this is the problem. I don't know those key codes. So I've just ChatGPT would work, but also this I could say processing key codes for arrow keys. And if I can't find it, we'll just use ASDF. Key code reference. There we go. It's I knew it had to be there, right? Key code. No, that's what we just saw. All right, so this is a project. I just don't want to deal with it, right? Sorry, folks. If key code equals, all right, so A is left. Key code equals D is right. Oh, instead of if, else, if, we could do switch on key code as case A, case D, case W, that's up, and case S is down. All right, so that's a little less typing, and it's kind of cool for those of you who don't know switch statement. What the hell? All right, so there we go. So now, Eugene, you were trying to say, so how do we go to the left? X, what? Yeah, let's just, yeah, I like it, right? Okay, so we're going to say final int dx equal 50, dy equal 50, so you could change those if you wish later. And now, all right, so this x plus equals dx, and this one should be y. Now you're going up, so I think that's y minus equals dy. And for s, y plus, plus equals dy. All right, there's one more thing you got to know about the switch statement, though. The switch statement will not just break out. If you say do A, it's going to do A, and then it's going to do D, and then it's going to do... So if you want to break out, you actually have to say break, which is really annoying. But, so we have to put breaks in every case. Kind of quirky, but that's the way it works. And this is C++ and Java. Everybody does it this way. All right, so here we go. Let's see what happens. Should be interesting. Okay, so I'm going to the left with an A. Ooh, it's working. I thought you were backwards, but it's right. But it is unfortunately blacking out the screen. So what's wrong? You need to wipe out the screen. So background, and if you want it, let's say you wanted a neutral gray, right? You could say all white is 255, 255, 255. Black would be all 0. So if you want it halfway, you could say 128, 128, 128, which I think is the default, by the way. But there is a shorthand. If you want all three guns to be the same, you could just say fill or background 128, and it does it. So there we go. Oh, wrong. I'm pressing the arrow keys expecting to. By God, it works. I thought you were backwards, but I was backwards. You had it right. Good for you. So S is down, W is up. Cha-ching. It's working. Okay, so that's kind of cool. So you see, if you wanted to like make some kind of like front end for your robot so you could like plot a course and you wanted to just get it done quickly, like in a weekend, this is the thing. Is it the most efficient thing going? Not at all. But it's so easy. It's amazing. So that's why it is the first topic in the workshop, because I wanted you all to have this experience that this is really fun. And I have been proposing for years to Stevens that they should have the intro class in programming use this. Why? Because every freshman does Arduino. And if you notice, the Arduino, they stole this. This came first. Arduino, they stole setup, and instead of calling it draw because they don't have a screen, they called it loop. So if you're doing Arduino, you're like, oh yeah, I recognize this. It's very similar. And at the level that we're doing it, this is C code, right? You can't tell this is Java. So if you did this for the first 6 weeks, okay, I take it back. P image isn't C, right? So if you're going to use a couple of objects here and there, that's not C. But all the logic you're using is C. So I keep telling them, like, you should do this because this is fun. And all the freshmen who complain currently about taking programming, like the civil engineers, they would say, oh, this is okay, right? I can make a little video game with my friends. I'll live with that, right? So this would just make the first course much more tolerable, and everybody would move much faster because they'd be interested. Anyway, so let's see, it's 8:01 now. I've got a few minutes left because I started late, so just let me save this out and make sure. So what we've done so far tonight is an intro to processing. What I showed you is that processing is not a language of its own, but it's a very, very clever Java front end that lets you ignore all the complexity of Java and just start writing code right away. Your first program could be one line. And we've done a few like 2D things. The one that we haven't done tonight is transformations. But what we did do is we went over how to like get input. So now you could write a video game, no question, right? This all becomes, if you don't know how to do function X, you have to look it up. I showed you the reference manual, but remember, Google's your friend. You could just say, Google, processing, how to do whatever, and or ChatGPT, actually. ChatGPT is aware of all this stuff, so it's really amazing. I have tested ChatGPT on some obscure languages, and it knows more than I do. I mean, I asked about stuff that I learned when I was like a kid at 11 or 12, like COBOL from 50 years ago. It knows. It knows everything. So, it doesn't know it perfectly, by the way. It makes mistakes. But, so the point is, if you have an ambition, this is not a bad thing to do a summer project in on your own. All right? So the last thing we're going to do tonight is transformations, because transforming your graphics is massively done in 3D. So to prepare for tomorrow night with 3D, this is what we're going to do. We're going to say void setup. All right, how do I open a window in processing? What do I say here? Size, and I give the size in X pixels and Y pixels. All right, so there we are. Now we are going to draw a line. Should we draw a line? Yeah, why not? We'll draw a line. So void draw. I want you to draw a line from the top left of the screen to, let's say, x equals 100, y equals 100. What would it be? Line of, what's the top left? 0, 0, 100, 100. There we go, right? So we'll run it, and you will see that there it is, right? But let's say I don't want it to be there. I want this thing to draw in the middle of the window, right? Now, of course, you could calculate it. You say, well, my window is 1,000 wide, so halfway is 500. My window is 500 high, halfway is 250. So sure, I could say this is 500, 250, and then I would have to add this to there, so I'd have to make this 600 and 350. And yes, it works, but wouldn't it be nice if you could just transform your coordinate system? And you can. All right, so I'm going to undo what we just did. So there are 3 transformations that everyone needs to know. They're called affine transformations, and they work uniformly. We're going to do them in 2D, and tomorrow we're going to do them in 3D, which is much more fun and a little bit crazier. Okay, so what you say is, the first thing is translate. So when you say translate, you're saying move the origin from where it is to somewhere else. So the origin is currently the top left of your window. How would we move it over halfway and down halfway so that this becomes the origin? What would I say here? How much do you move it over in the X? And that's the way to say it. Don't say 500, say width over 2. This way, if you change the size of your window, it still works. Always use the variables when you can. And so the other one is height divided by 2. And check it out, we save it. Oops, I have to save that thing. Okay, this is SO4 transforms. All right, and we run. And there it is. Okay, so you've just transformed it. Now, what else can you do? So the first kind of transformation is to translate. The second kind of transformation is to scale it up. Make it bigger. So if we say scale, now if we just say scale 2, we're saying just double everything in every dimension, right? So not only is it going to make the line twice as long, it's going to make the line twice as thick, which is weird. So here, check it out. You see, it got bolder, right? Because it didn't just get bigger. The line got wider in the perpendicular direction too. So the line, you have to understand that the thickness of a line by default is 1, and that's going to do some weird things. So if I will now make it, I'm going to shrink the line by a factor of 10. So it's line to 10, 10. But now I'm going to scale it up by 20, and watch what happens. Okay, so now, yes, it's still the same length as it used to be, but it's a lot fatter, right? Because I amplified everything about the line. If you still want a thin line, every graphic system has this problem, by the way. OpenGL, everybody does the same stuff, which is kind of annoying. What you can do is you could say line width. Wait. No, not line width, sorry. Stroke width. Okay, that's one of these things you could do in the beginning of your program if you wish. So you don't have to do this every time. You could just say, you'll set the size to this and set the stroke width to 0. And if you say 0, this means make the thinnest line you can no matter what. So now it will be a paper thin line, but it'll be the same length. Let's see. Stroke width, it didn't work. Function stroke width does not exist. Oh God, stroke weight. Oh my. Well, it caught me, right? And you see the color immediately changed, so I should have known better. There we go. All right. So we've done 2 out of the 3 and we're almost ready to quit. So translate moves the origin. Scale amplifies everything. And rotate rotates around an axis. Now in 2D, we're talking about rotating like this. Here, look at the camera. Like this. But in 3D, we can rotate it on anything. So it gets crazy and very cool. So what we're going to say is the following. We're going to make a radar. Oops. Float A equals 0. So my angle starts out at angle 0. And we're going to say rotate around A. So what just happened is we used to have our x coordinate was here and our y is here. But every time we rotate, it's gonna rotate like this. It's gonna spin. Now it should rotate in the counterclockwise direction, but it's not going to because we're flipped from the way math works. We have our y going down positive. So in order to do that, we would have to flip it so that y is up, and I'll show you how to do that in a minute. Anyway, so let's just do this. Oh, whoops. Wait, I'm always drawing line 1010. Let's draw line R0. Okay, let's say float R equals 10. And I forgot A plus equals. Every time we draw, we need to like rotate. So let's just increase the angle by, this in radians, so like 1/100th of a radian. All right, let's see our rotating radar. There we go. And you're seeing these beautiful moire patterns come out. They're interference patterns. You know, the line is not perfectly hitting every dot, so you're getting these interesting. Isn't that cool? I love that stuff. Moire patterns. All right, so there's our little radar spinning around doing its thing. Any questions? I know tonight hasn't been very interactive because we were just kind of blasting through stuff. So it's your chance to play with this stuff after. I'll stick around if you want to play a bit and ask me questions. But all right. So the 3 transformations. Tomorrow we will do OpenGL. Translate, rotate, and scale. And I promise tomorrow I'll just go real slow. We're going to use this, but we're just I will wait for everybody. If you want to do it in lockstep with me, we can do it. Tomorrow we will do this stuff, but in 3D, which is really fun. That's my favorite thing. That's why I decided to do it, because it's really great stuff. All right, so any questions? I will stick around if anybody wants to share a screen and just see if you can get stuff working if you have a problem. 3, affine transformation. You can translate to move your axis. You can rotate so that your frame of reference rotates. And you can scale to magnify things. Oh, and I promised you I would scale 20 and -20. By doing this, I just flipped the y-axis upside down, and now it should go counterclockwise. Wait a minute, it's going clockwise. Interesting. What have I done? I think I have to scale first, possible. Yeah, order matters. Oh, deadly. Okay, so I'm going to stop the recording now, and anybody who has questions, just share screen and show me what you got, and we can make whatever it is that you couldn't get working in real time work. And otherwise, thank you very much, everybody. I'll see you tomorrow night. How do I stop the screen recorder? Here it is, simple screen recorder right there.